I hope this isn't too dark. My light blew out and I haven't had a chance to fix it. And I put a lamp on instead, so we'll see if this is better or worse. So part 284C3M1b7c8e13c9c6d1b. Line 22f1fa19c3m1b7c8e 13c9c6d1b. Plasma etching ions fuel formula UFO 5D Wow Seti. Here's our alien radio signal. This is a keyword research for plasma etching PE plus gas ionization, nuclear fusion, power engine, fuel, X-rays, xenon, laser beams, and UFO fuel formulas, alien technology ideas from WOW. I'm going to be Googling the keywords from the data, liquid argon gas, and oxygen plasma in the next video. So January 14th, 2013, today's date. Keyword plasma etching PE from the previous video, line 22f1fa19c3m1b7c8e 13c9c6d1b gas ions, plasma etching wafers 5G Wow Seti. So this is a plasma etching PE. As its name tells, plasma etching, that will note more commonly PE. It's done by ionizing a gas mix inside a chamber to obtain ions that will react with the target material. So here's a diagram showing the gases input. This is your chamber, your plasma, and your ionized gases. The target wafers right there. Your gases evacuation holes. Then you have your bottom electrode connect to ground. And then top electrode connect to an RF source. So before etching, there's a mask, a target layer, and a bulk wafer. End of etching, that's what it looks like. So schematics of the principle of plasma etching. The ionization of the gases is done by RF excitation emitted by electrode at the top of the chamber. The target wafer is placed on an electrode connected to the ground. The pressure inside the chamber is in the range of a few Mtoor to a few hundreds of Mtoor. The random movements of the ions inside the chamber make them reach the target, and a chemical reaction etches this material. Plasma etching makes highly isotropic etching. The process depends, of course, on the chamber's geometry that is not controllable. What the operator has to set as parameters are gas flow, pressure, and RF power. As for every etching techniques, the gas's nature determine the efficiency and selectivity of the etching. This is the first point to choose when calibrating an etching recipe. An equilibrium between RF power and gas flow controls of the ionization rate of the gases, while a higher pressure increases the probability of ions to get in contact with the target material. Also note that the gases flows control the rate at which the products are evacuated from the chamber. RIE is a variation of PE. The principle of etching device is almost the same, but this time the chamber top electrode is connected to the ground, and the wafer is placed on the excitation electrode. This makes a large difference. So reactive ion etching. So in RIE, the products are accelerated in the direction of the wafer. This has consequences on the etching process, especially if you want a more anisotropic etching. So it shows gas input, top electrode, chamber, target wafer, bottom electrode connected to RF source, and gas outputs. Since the wafer is connected to the RF signal instead of the ground in PE case, electrons are statistically more often in contact with the target than positive ions. They are far lighter. Electrons are highly reactive species, so they are easily absorbed by the target material, polarizing it negatively. In the same time, the loss of electrons in the plasma makes a global positive charge in the ion cloud. This produces an acceleration of the ions towards the wafer. So here's your ions cloud, heavier, losing electrons. Electric field generated between ion cloud and wafer, so you could generate a Higgs field there. Acceleration of the ions cloud, electrons moving fast and absorbed by water, RF power on. So this is kind of a way that you could generate a Higgs, your Higgs field within your water vapor invention that we've got on the WOW data from line 22. Schematics of the RIE effect. First noticeable effect is the apparition of another etching phenomenon due to the ion's velocity, physical etching. The layer molecules are stripped away by impact of ions on the wafer. Physical etching is characterized, of course, but by very low selectivity, but is highly anisotropic. The second effect is that contrary to plasma etching, where ions move randomly above the target in reactive ion etching, they have a higher probability to have a movement in the direction given by the electric field. This makes a tendency to anisotropic etching. So here's the acceleration of the ions by the electric field, chemical etching by reaction of accelerated ions in target layer material, and molecules stripped by physical etching. So you can strip molecules and gather the atoms from them, right? Target layer polarized by absorbed electrons. Schematics of the physical and vertically directed chemical etching in RIE. RIE offers the possibility to set up anisotropic etching recipes. This depends on the type of material to etch. If it has a poor capability to absorb electrons and polarize, RIE produces the same effects. Not much difference. On the contrary, a material with a high capacity to absorb electrons allows the calibration of highly anisotropic recipes. Dielectric materials have a poor electron absorption capacity. Semiconductors a higher one. So this is some sort of semiconductor you can use it with. So anisotropic etching recipes concern mainly silicon, polysilicon, composite materials, etc. The difficulty of the calibration is an equilibrium to find so that the plasma provides a lot of electrons and ions. The electrons are absorbed to the surface, ions etch the surface, but not too fast so that the electrons have a long time enough to be absorbed again, or you get an isotropic etching again. Sometimes the chemical reaction products must play a role in the process to enhance anisotropy. Getting a high etching rate during an anisotropic etching is not so easy task, and calibrating a recipe can need lots of tries. Compared to PE, RIE has a lot of advantages in terms of anisotropy. Another kind of etching device is more evolved, have been developed to get even higher anisotropy in etching process. An ion beam etching, also called ion beam milling. Ion beam etching is the extreme case of physical etching. It consists in using very high energy in a neutral gas, argon, so we have our liquid argon gas, to make a pure physical etching of wafers. O2 plasma stripper. Completely opposed to ICP, other use of plasma etching can be seen through the study of the O2 plasma stripper. Here plasma is generated by microwaves. So we were using plasma with microwaves, right? And the goal is to avoid any physical etching while keeping an efficient chemical etching. Examples of recipes and reactions. And this is the website. Matthew.lagouge. Okay, there you go. MATTHIU.LAGOUGE.free.fr. Keyword from data is O2 plasma stripper. Quote from Wiki: in semiconductor manufacturing, plasma etching is the process of removing the photoresist from an etched wafer. Using a plasma source, a monatomic reactive species is generated. Oxygen or fluorine are the most common reactive species. The reactive species combines with the photoresist to form ash, which is removed with a vacuum pump. Typically, monoatomic single-atom oxygen plasma is created by exposing oxygen gas at a low pressure, O2, to high-power radio waves, which ionize it. So January 14th, formula from the data: ions, plasma, fast, gas, highly ionized gas, cloud, vapor, long-distance deep space communication signal, neutral, electric charge, energy, excite molecules, high energy, xenon, neutrino, X-ray, microwave, pencil laser beam, ligands, links, break up, ions separate. Microtechnology: plasma, increased temperature, electromagnetic excitation, piezoelectricity, dry etching, plasma, forced state of matter, dark matter. Ionization: molecules form gas, chemicals, highly reactive, nuclear fusion reaction. Plasma, microtechnology processing. Plasma etching: PE, ionize, gas, mix, vacuum chamber, create ions, react, target material, graphite films. Top electrode, gas, chamber, plasma, ionized gases, target wafer, graphite, electron holes, gas, evacuation holes, bottom electrode, -W, -Z bosons, connected to ground, RF source, laser beam, excite, ray, plus Mtoor. So I'm going to Google the keywords from the data: liquid argon gas and oxygen plasma. I don't know if I Googled the Mtoor or not. Thanks for watching.